Welcome to today's explainer. Let's get right into it, because today we're going to empower you to finally understand exactly how your computer works from the absolute ground up. Whether you're gearing up to upgrade your workstation or you just really want to know what's actually happening inside that glowing box on your desk, you are absolutely in the right place.
Okay, let's kick things off with a totally familiar situation. You're trying to buy a new computer, maybe a sleek laptop for work or a beefy desktop for home. You pull up the list of features, and suddenly, it's like you're reading a completely alien language. It's just this massive jumble of letters and numbers that honestly seem designed to confuse you rather than, actually inform you.
And this brilliantly illustrates the exact problem we're facing. Take a look at this advertisement. It is packed to the brim with acronyms. 3.9 GHz, 32 GB DDR3 SRAM, 128 KB L1 cache. For the everyday consumer, this is completely overwhelming. What are you actually paying for here? Why is one machine wildly more expensive than another when the ads look basically identical? Well, don't worry, because we're going to decode all of this today.
To solve this mystery, here is our roadmap for the explainer. 1. Decoding computer specs. 2. Hardware versus software. 3. The principle of equivalence. 4. Processing, memory, and transfer. And finally, number 5. System versus application software.
All right, let's jump straight into Section 1, Decoding Computer Specs, Making Sense of the Jargon.
Now, notice how this advertisement just kind of expects you to intrinsically know what 3.06 gigahertz or 4 GB SD-RAM actually means for your daily tasks. It casually lists a 500 gigabyte hard drive spinning at 7,200 RPM and expects you to just calculate the value on the spot, right? So rather than just guessing what these numbers mean, let's take a step back, completely forget the math for a second, and build a real foundational understanding of how these machines actually operate.
Which brings us to Section 2, Hardware versus Software, the physical and the invisible.
So the absolutely crucial point here is that hardware represents the physical, tangible objects, the stuff you can literally touch. We're talking about the monitor, the mouse, the keyboard, the hard drive, and the actual physical chips inside the case. Software, on the flip side, is the invisible set of instructions. It's the data that translates your specific needs into computer action. Basically, anything that can be stored electronically is software. It is the ghost in the machine telling the physical processor exactly what to do and how to do it.
Okay, Section 3, the principle of equivalence, the mind-bending rule of computing.
This is known as the principle of equivalence of hardware and software. And honestly, it proves that these two seemingly opposite sides, the physical and the invisible, are incredibly intertwined at a really fundamental level. We tend to think of them as strictly separate, right? But theoretically, if you have an operation done by a physical microchip, you could write a software program to do the exact same thing, and vice versa. A task currently done by software could literally be hardwired into a physical circuit. It's pretty wild to think about.
Moving on to Section 4, Processing, Memory, and Transfer, the Big Three. At the most basic architectural level, every single computer consists of just these three primary pieces. First, you have a central processing unit, or processor, that acts as the brain to fetch, decode, and execute programs. Second, you have memory, which stores your data and instructions temporarily. And third, you have the input-output system, or I/O, which is the whole mechanism for transferring data to and from the outside world. Think about it. If a computer didn't have an I/O system, it couldn't talk to a keyboard or a screen. It would literally just be a rock doing math in the dark, completely useless to us.
Armed with that knowledge, we can finally decode our ad. When you see GHz or gigahertz, it measures the speed of that brain component, the processor. Hertz simply means clock cycles per second. So 1 megahertz is 1 million cycles, which means 1 gigahertz is 1 billion cycles per second. An Intel processor running at 3.9 gigahertz, that means it's ticking almost 4 billion times every single second, executing program instructions with just incredible, mind-blowing speed. Next up on the ad is usually RAM, which stands for Random Access Memory. Think of this exactly like your working desk space. Random access just means the memory contents can be accessed directly if the computer knows the location. Main memory access times are measured in nanoseconds, literally billionths of a second. So a larger gigabyte capacity of RAM means you simply have a bigger desk. You can have more papers out, meaning you can run larger, more complex programs way faster without the computer having to constantly shuffle files away into storage.
Finally, you'll often see cache listed on these spec sheets.
usually in much smaller amounts like kilobytes or megabytes. Cache is like the processor's immediate short-term thought process. It's a highly specialized type of temporary memory that can be accessed even faster than standard RAM. The computer uses it to stash the tiny bits of data it knows it's going to need again right this very second. That way, it prevents the processor from having to reach all the way back into the main RAM disk space.
All right, Section 5, System versus Application Software, Layering the Machine.
Think of modern computing like a perfectly layered stack. At the very bottom, you have the cold, physical hardware. But you, the user sitting at the top, you don't interact with the hardware directly. The operating system sits right in the middle. It acts as this vital middleman, constantly coordinating the complex interactions between the physical chips, your specific application software, and your actual inputs.
The distinction between these software layers is absolutely vital. System software, which is primarily your operating system, like Windows, macOS, or Linux, runs the background operations. It manages the files, the memory, the processor. Application software, on the other hand, performs specific information processing tasks for you, the end user. This is your Microsoft Word, Excel, your web browser, or your favorite video game. Applications literally require the system software to even function.
So, let's bring it all together. The next time you are shopping for a laptop, you're going to know exactly what you are paying for. You can confidently distinguish the temporary working disk space of your RAM from the raw billion cycles per second brain power of your processor. You understand that hardware is the physical machine, and software is the invisible instructions, perfectly layered to give you that smooth user experience.
But I'll leave you to ponder this as we wrap up today's explainer. Considering that principle of equivalence we discussed earlier, the fact that hardware and software can essentially perform the same tasks, and looking at the massive rise of cloud computing where remote servers are providing your storage and processing over the internet, where exactly is the boundary of your personal machine today? I mean, if your software is acting as virtual hardware in someone else's massive data center, what really is a computer anymore? Think about that the next time you look at a spec sheet. Thanks for hanging out with me today to explore this and keep learning.